So now that I've scared you to death with enantiomers and diastereomers and homeotopic, let me give you some general rules on how we're going to identify chemically identical protons. First is that the 3 protons that are associated with a methyl group will always be chemically equivalent. So the 3 protons on a CH3 will be identical. Okay? The 2 protons on a CH2 group generally are identical. The only exceptions really are if you have a chiral compound. Exception, chiral compounds. And 3, two CH2 groups are equivalent if the CH2 groups can be interchanged. Either by rotation or reflection. So let's look at this compound below and identify the number of different signals we would expect to get. So this is a methyl group. It's going to have 3 hydrogens on it. They're all going to be the same. So that's one signal. Okay, there are no hydrogens here, no hydrogens here, and no hydrogens there. Let's get my different colors out here. That there are 2 hydrogens here that are going to be identical to each other because there's no chiralness involved. These 2 will be identical to the ones on the other side. Okay. The 3 hydrogens that are here will be identical to each other. That's like a methyl group. And they'll also be identical to the ones on the other side because we've got symmetry. The methyl group, the proton that's here will be identical to the proton that's there because of symmetry. And I'm about to run out of colors. We'll do light green down here. So we'd expect to have 1, 2, 3, 5 different types of protons and 5 signals. So now I've got a whole bunch of examples. You might want to stop the tape and see how you do on these. So there's 3 protons here. Oops. The 3 protons here will be of one type. The 2 protons at this position will be of another type. The 3 protons on this methyl group will be yet another type. There's a proton here. There's not a proton, no proton here, but we've got one here and here, and no symmetry. There's a proton here and a proton here. So we're going to have 8 different types of protons. And so we'll expect to have 8 signals. Note that there are 3 protons here, but they all have the same signal. Okay, so let's look at this one. This one has more symmetry to it. The protons on this methyl group will give a signal. And then the protons here and here will give the same signal. So we're going to put a 2 by both of those. These, the protons here and here, will give the same signal. There's no proton here, and there will be 3 protons at this position, and they'll give off a 4th signal. So we'll expect to have 4 different signals. I'm counting signals, not number of protons, just so you know. Okay, so the protons on this methyl group will give off a signal, and it will be identical to the signal given off by the protons on the other end. There are protons here, 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 and here, and they will all give off the same signal. So we'll only have 2 signals. Here, these will be the same. There are no protons here. These 2 will be the same, and these will be the same. So there are 3 signals. There will be a signal here. Then the signals off this proton and this proton will be the same, and this proton will be different. So we'll get 3 signals. So if you didn't stop it last time, stop it this time and try these before you go on. I'm going to change colors so we know which ones we're naming. The proton here will give off a signal. The proton here will give off a signal. It's not the same as the proton on the other side because we've got chlorine on this side and a bromine on that side. So this one will be a 3rd signal, and this one will be a 4th signal. So there'll be 4 signals for this compound. So let's change color again. So the methyl groups here are all identical. So they will give off a single signal. There'll be just 1 signal. And there'll be a signal from those. So this one will only have 2 signals. We've got symmetry this way and symmetry this way. Okay. The methyl group here has 4 protons. They will give off a single signal. No protons at the next carbon. This carbon will give off a different signal. They have 2 protons there. They'll give off 1 signal. And 2 protons here will give off 1 signal, and the 3 protons on the end will give off 1 signal. So there'll be 4 signals. So how many signals do you expect to come from this compound? And this one's a little tricky because we've got this double bond here. The signal from these 3 protons will be different from those 3 protons. Because these are cis, and that's a trans. The number 2 there is a trans. So 1 and 2, there'll be a 3rd signal from the proton here, 4th signal from the 2 that are at this location, a 5th signal from the 2 that are at this location, 6 is there, 7 here, 8 here, and then let's not forget that will be number 9. So we'll have 9 signals. Do need to pay attention when you have a double bond like that. Just as kind